So the goal in this problem is to rewrite this thing here without using any trig functions and only using t's and pluses and minuses and roots and squares and stuff like that. Stuff from regular algebra. No trig. Uh, so the way to do that is, first, notice we're dealing with secant inverse. So secant inverse, it's like cosine inverse in terms of the range that you get back. So secant inverse will give you stuff in the top half, anything between 0 and pi radians only. So if we do secant inverse of t and call that theta, because really that's an angle, then that's the same thing as saying secant theta has to equal t, but theta's got to be between 0 and 2 pi, or 0 and pi. And remember, secant is defined as r over y. Is that right? No, sorry, r over x. Yeah, r over x. So what we could do is think of t as the radius and 1 as our x-coordinate. You could do it 2t and 2 or half a t and half, but might as well just go as simple as possible. So t over 1. So the radius will be t, and the x value will be 1. So that would put us over here. X value is 1, radius is t. Can't be over here because then the x value would be -1 and the radius would be negative t, which is not going to work. So it's got to be in that first quadrant there. Okay, so now we've got our theta, and the question is, what's sine of that theta? Okay, well, sine of this theta right here, of that angle, theta, is going to be, so now we're calculating this. Sine of theta is going to be the y value over the radius, right? Well, the radius is t. That's what we figured out. But the y value we don't have. We need to calculate that. But you do know that you have a triangle here that's got a 1 and a t. And so if you did Pythag, you're going to get t squared minus 1 right there underneath the root. And it's got to be positive because it's going upwards, not downwards. So the y value right here, t squared minus 1. And so there is another way of writing this thing.